Picture this. About 4.6 billion years ago, a dense cloud of gas and dust swirling around the young sun begins to coalesce into a protoplanetary disk. This is the birth of our solar system, and among it, the planet we now know as Venus. From this primordial soup, Venus began to take shape, amassing mass from the surrounding matter. It was a time of creation and chaos, as particles collided and coalesced, gradually forming the planet's dense iron core and rocky mantle. This was Venus in its infancy, a world in the making, being forged in the heat and dust of the early solar system. Its formation, though, was just the beginning. Venus, like its celestial siblings, had embarked on a journey of transformation. So, Venus began much like any other planet in our solar system, but its proximity to the sun would set it on a unique path. In its early days, Venus wasn't so different from Earth. It had a thinner atmosphere, and even liquid water on its surface. But being closer to the sun, it was subject to a more intense greenhouse effect. This effect is essentially a warming process, where the planet's atmosphere traps heat radiating from the planet back into space. Now imagine this process, but amplified. Venus, being closer to the sun, experienced a stronger greenhouse effect. As the sun's luminosity increased over billions of years, this warming process on Venus intensified. The heat trapped by the atmosphere started to increase. This was the beginning of a runaway heating process, a vicious cycle where more heat meant more intense greenhouse effect, which in turn meant even more heat. This cycle set the stage for a profound transformation, turning Venus from an Earth-like planet into something quite different. As the heat trapped by Venus's atmosphere increased, the planet began to change dramatically. Around 700 to 800 million years ago, Venus's transformation took a drastic turn. The runaway greenhouse effect set in, causing a heating frenzy. This effect, as you may know, kicks in when a planet's atmosphere traps so much heat that the surface temperature skyrockets. For Venus, the consequences were far-reaching. The escalating heat resulted in the evaporation of surface water. But it didn't stop there. The intense heat also caused rocks to release carbon dioxide into the atmosphere, adding fuel to the already raging greenhouse effect. As the temperatures continued their upward climb, the water vapor in the atmosphere began to break down. Hydrogen atoms, light and eager to escape, floated off into space. Meanwhile, oxygen atoms found a new home by combining with surface rocks. The high temperatures resulted in the breakdown of water vapor, with hydrogen atoms escaping into space, and oxygen combining with surface rocks. Venus was losing its surface water. Today, Venus has an extremely thick atmosphere, composed mostly of carbon dioxide. This dense atmosphere exerts intense pressure on the planet's surface, making it the hottest planet in our solar system. Venus's unique atmospheric conditions bear testament to its fiery past and present. With a pressure at the surface more than 90 times that of Earth, it's akin to being 1 kilometer under the ocean's surface. This thick atmosphere acts like a blanket, trapping heat and contributing to surface temperatures that can reach an astonishing 900 degrees Fahrenheit, hotter than the surface of Mercury, despite being further from the sun. But what's even more intriguing about Venus's atmosphere is its constant state of motion. The upper layers whip around the planet at breakneck speeds, creating a phenomenon known as superrotation. This atmospheric superrotation whips clouds around the planet every 4 Earth days, despite the fact that Venus itself takes 243 Earth days to complete one rotation. Moving on to the planet's surface, we find a landscape dominated by volcanic features. From vast volcanic plains that stretch for thousands of miles to towering shield volcanoes, Venus's surface is a testament to its turbulent geological history, and it's not just a thing of the past. Venus is still volcanically active today, with recent data suggesting that molten rock may still be flowing beneath its surface. This volcanic activity has led to a process known as surface renewal. As fresh lava flows over the landscape, it covers older terrain and creates new features. This process, however, is quite different from what we see on Earth. On our home planet, tectonic activity helps to recycle the surface, creating a dynamic and ever-changing landscape. But on Venus, where tectonic plates are seemingly absent, this renewal process is primarily driven by volcanic eruptions. Despite its intense heat and pressure, Venus continues to evolve, shaped by its volcanic activity. Its surface, scarred by lava flows, tells the story of its dramatic history. Understanding Venus's transformation is more than just a journey into the past of a distant planet. It's an exploration of cosmic processes, a testament to the power of nature to shape and mold celestial bodies over billions of years. It's a study in planetary evolution, a lesson in atmospheric dynamics, and a warning of the potential consequences of runaway greenhouse effects. The story of Venus serves as a reminder of the dynamic and ever-changing nature of planets, and perhaps a glimpse into the possible future of our own world.